Okay, here we are on page 4. I'm just going to check the focus here for just a moment. Yep, that looks pretty good. I know it kind of goes in and out. I can't figure out why that camera does that, but it does, so we'll just deal with it. Okay, 2.6, page 4 on the bottom here. Now, I'd like you to try these, number 82 or number 88. Ideally, you try them both. And I just want to give you a heads up here. I want you to pause and then try, but notice right underneath I asked the question, what happened? The last time I asked this question when we were solving equations, something very different happened. So I want you to do what you can solving this, and then realize that there's a reason why I picked these. I wanted to walk through these. So do your best, hit pause, try them, and then come back and we'll talk through what did happen. Okay, so hopefully you paused and tried working these out. I'm not going to work these out right now. I'm just going to describe what happened. And in both cases, when you tried to move x to one side or the other, what happened was it all canceled out, or x fell away, or it disappeared. Okay, so that's what happens in both of these. X falls out. Okay, what then you're left with something like, depending on how you move things around, but on the left side you might have been left with like -5 is less than -6. On the right side, maybe you got 10 is greater than 0. If anybody remembers what happened when there were equal signs involved in the beginning of chapter 2, these were two very different situations. Why? Well, -5 is less than -6. Is -5 to the left of -6 on the number line? No. -6 is less than -5. Okay? Less than is left on the number line. So this is a false statement. But 10 is greater than 0, that one's a true statement. Okay? So even though x falls out in both of these as you're solving them, and you're left with a inequality that just is comparing numbers, you need to look at what that comparison is. So examine the comparison of numbers to determine if it's true or false. Now in this first case, if it's false, what that means is it's that there's no solution. There is no value that you can plug into this inequality to make it true. Okay? There's no value for x that you can plug in to make it true. Okay, so no solution. So we just use the little circle with the slash through it, meaning it's the empty set. There's no set of solutions that works here. However, if a true statement shows up, you can say that's all real numbers. In interval notation, that would look like from -infinity to +infinity, everything works. Okay, now the book uses a more fancified version of set notation here. They say x such that, this little straight up and down line, it means such that. Just gonna check my battery, good. Such that x is a real number. I'm not as concerned about that set notation right now. We'll get there in 65, for sure in 95. But this is the, x is a real number. This is the official, big-time, grown-up, long version of set notation. Okay? So this is the official or long version of set notation. And I'll write it again because I kind of, x such that x is a real number. I kind of goofed and didn't get number quite in that brace the first time. Okay. What does that mean? That means that every value you plug in for x makes that statement true. Every real value you plug in for x makes it true. Okay? So when you have the variables fall out and poof, they go away as you're trying to move them from one side or the other, or you combine like terms and poof, they go away. first, double check that you did the math right to make sure you aren't creating something that isn't there. But if it truly does fall out, then look at the comparison of the numbers that's left. And if it's a false statement, you go to no solution. If it's a true statement, you go to all real numbers. Okay? And then page 168 has a reminder of that in the book, the way the author would describe that. All right, we'll see you on page 5.